4.8. In this lecture video, I'm going to show you how we can use the compound interest formula for inflation and depreciation problem. All right, so let me just copy this. So this is for inflation. So the inflation formula is very similar to the compound interest formula, just with a little bit of modification. So there's no and, okay, in the formula because inflation and depreciation is where it's calculated annually. So n is always equal to 1. So if we take off the n, assuming it's always 1, then the compound interest formula will look like this. Now for depreciation, I meant to put the formula up here, but I didn't. For depreciation, is actually, instead of plus sign, it will actually be a minus sign. Okay, 1 minus the r to the t power. All right, so the same compound interest formula can show us money grows on tree, make us a lot of money. But at the same time, though, it's also used kind of against us on the inflation and depreciation. Okay, inflation is kind of is inevitable to happen. Okay, things just tend to cost more over time because there are different reasons, but basically nobody wants to make less money. So if everybody wants to make more money, the cost of goods naturally will go up. All right, the cost of labor goes up, or the cost of material might go up. Therefore, the cost of goods for consumer like you and I will go up as well. So inflation sometimes is good, sometimes is bad, depends on the situation. All right, so this example is actually a good thing. If you own your house, the value of a house is $195,000 today. Okay, based on the depends on the housing market, and inflation is constant at 10.9% annually. So when you see this inflation, when you see the wording inflation, you think about this modified compound interest formula. All right, what would be its value to the nearest $1,000 in 16 years? Okay, 16 years later. So that will be $195,000 today times 1 plus 10.9% is 0.10. 0.1 is 10% already. 0.9 raised into the 16 power because it's 16 years. Okay, so the same house, if the market in this particular hood is inflation at 10.9% annually, how much would your house worth after 16 years? So let's check it out. 195,000 times 1 plus 0.109, close parenthesis, whole thing raised into the 16 power. The same house appreciate into that number, 1020 796.92, 796.92. So that would be over $1 million. Okay. So that's inflation, which is good because as long as the housing market holds up, okay, the value of house tend to go up over time. If we just kind of change this to a 5% inflation rate, just 5%, let's just say 0.04, right? 4%, 5%, 0.05. For 16 years, the house has become a little bit over $425,000, okay? All right. So this problem want me to round to nearest $1,000. So $1,000 is this zero right here. So the 7 will make my 0 go up to a 1. Everything else in front of it stays the same. Everybody behind it becomes 0. So that will be $1,021,000. All right, let's take a look at a couple more. All right, depreciation. Okay, talk about a car, using a car example in the last lecture video. So a brand new van valued at $36,200. What will its value be in 1 year if you depreciate at 12.5% each year? So depreciation, when you see the word depreciation, you think about the same modified compound interest formula, except it's a minus the interest rate raised to the t power, okay? So take my brand new van times 1 minus depreciate 12.5% is 0.125, raising to 1 year. I'm only gonna do a 1 year. 36200 times 1 minus 0.125, whole thing to the first power. So the value of my van become 31,675. So as you know, some car manufacturer says their car holds up its value better. Yes, that do exist. Okay, some car is holds its value a little bit better than others for various reasons. However, old cars depreciates. Okay, unless it's classic cars. Classic cars actually go up in value, but that's after many years later. Okay, so one of the key reason why a classic car goes up in value because they are scarce and people like them. So that creates some sort of markable value to that car. Otherwise, 69 Mustang, most of them is actually in the junkyard. But if you can keep up with it, that same car become a classic car can actually value some money. All right, so that's depreciation. So if I use the same formula, and let's think about our 60-month payment, which is 5 years later, that car can depreciate down to $18,000. Okay, opportunity cost. Suppose that your income is $22,000, $300 per year, and you receive a cost of living raise each year. So let's assume if the inflation is constant at 7.4% annually, in how many years? Oh, this is an interesting problem. In how many years would you be making $35,000? So this is the future. So this capital letter A in the formula, sometimes we call them the future value as well, right? Because it's referring to the amount of money in the future. With the compound interest or even with the inflation, it's referring to money of value in the future. So now my future, I'm setting my goal for the future at $35,000. Currently, I'm making $22,000. 300 times 1 plus R, because this is inflation, so that will be 1 plus 0.074, right? R is 7.4%, 0.074, raised into the t power. Okay, in how many years? So the question is asking for this t. Run your answer to the nearest whole number. All right. So let's take a look. Run your answer to the nearest whole number. So there's actually a different way we can do this. Okay. Let's do what's inside this parenthesis. So basically what I got myself here is 1 plus 0.074, which is 1.074 to the t power. Okay, the other side is $35,000. So divide both. So this is a little bit involving with algebra. So I really not intend to show you all this algebra. We actually do a problem similar to this in our college algebra course. So this is what I'm going to do. Okay, I am going to show you how to do this just by plugging different numbers for the time. Okay, we can kind of estimate it because I still need to run to this whole number anyway. So 22,300 times 1 plus 0.074 raised to the first power. So that would be 23,000, right? So let's keep going. So here's the way how you do it. If you use a scientific calculator, just scroll back up and it'll allow you to edit the 1 year to other numbers. But for graphing calculator, I gotta press second entry. Change my cursors right here now, changing that 1 to a 2. That's 25,000. All right, let's go up. Let's just do 10 for right now. See where it take me to. 10 is 45. That's way too big. Way bigger than my 35,000. So maybe we can go up to 5 maybe. Change that to a 5. That's 31,000. 6. 34,000. So I'm getting close to 35,000. Do it one more time. 7. That's 36,000. All right. So let's do. So I know it's going to be between 6 and 7 years, but which one do I round to? So I'm going to do 6.5. Okay, raising to 6.5 power. If this 6.5 power is actually going to be, depends on how big they are to 35,000, then I will know how to round. So this is actually over. 6.5 will actually push me over. So if I do 6.4, that is actually slightly over. Okay, so that means my approximation is about 6 years. Okay, if I round to the nearest whole number, all right, 6 years. 6 years will actually put me right there, very near $35,000. Alrighty. So if we check out the same problem, if you check out the same exact problem in on your homework, they will probably show you a different way how to do this one. So the way I'm showing you is kind of do an estimation of the time. Okay, I think that will suffice. If 6 is not the answer, that means they will always run up to the next whole number, but it doesn't quite say that. So try with your estimation first. If that does not work, maybe go up 1 additional years. Okay, because we know 1 additional year will definitely top you over 35,000. Alrighty, so that will conclude this lecture video. Thank you for watching on inflation and depreciation.